Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. The title of my presentation today is the elucidation of the structure, physical properties, photocatalytic activity relationship using density functional theory and the fuzzy logic graph. So in this presentation, we want to combine experimental work with the computational and also mathematical approach called fuzzy logic graph. Yeah. So in this study, we use titanium dioxide as a photocatalyst. We know that this material is a photostable, non-toxic, high abundance, and it has a superior oxidation ability. Yeah. So the structure of a photocatalyst is same with the electronics structure of the semiconductor, where this material has a conduction band at high energy levels and valence bands at a low energy level. And the valence and conduction band is separated by the band gap energy, by band gap energy. So the reaction of the photocatalysis occurs by the excitation of the electrons from valence band to conduction band, and we leave the hole at the valence band. Then there will be a recombination process where the electron and hole will recombine. This process is called the redox combine process. The electron is reduction active site, and the hole is the oxidation active site in the photocatalytic reaction. Therefore, to produce a high photocatalytic activity, electron and hole recombination are necessary to reduce in order to, or avoid in order, or electron and hole work effectively as reduction and oxidation active site. So if we look at the requirement for the high photocatalyst, high active photocatalyst, it has been generally proposed that to avoid recombination, it usually needs a material that has high crystallinity and also high surface area. So by using this kind of properties of material, electron and hole can be used for the chemical reaction effectively. If not, they will recombine. So I have three examples here. On this slide, the trend of the photocatalytic activity of some reaction is shown. Before this, we know that the crystallinity and surface area affect the photocatalytic reaction. And the first example for the oxidation of methanol to aldehyde, both high crystallinity and high surface area, and also the presence of the anatase and rutile phases, play a role in photocatalytic oxidation of methanol to aldehyde. And in the second example, for the oxidation of water to oxygen, the crystallinity is more dominant factor compared to the surface area, and the reaction only active with the presence of the rutile phase. And the third example for the oxidation of water to hydroxyl radical, surface area is a dominant factor compared to the surface area, whereas anatase is the active site. Based on this example, it can be concluded that the most important factor affecting photocatalytic activity is altered depending on the kind of the reaction. So this is some challenge in the titanium dioxide photocatalysis. Is number one is to prove the predominant properties determine the photocatalytic activities. The second is that how does the shape of photocatalyst affect the photocatalytic activity? So we need to have the approach to how to elucidate the structure, physical properties, photocatalytic activity relationship. In this approach, we use DFT, density functional theory, and fuzzy logic graph. So I will demonstrate the two of the example. Number one is a SEP control titania containing 5Cb liquid crystal photocatalyst. And the second is a carbon modified titania photocatalysis, in order to know that what the predominant properties determining the photocatalytic activity. The first topic is on how to demonstrate the shape of the photocatalyst affects the photocatalytic activity. Here we synthesize one-dimensional light, yeah, titania, that is titania 4-phentyl 4-biphenyl carbonitrile composite, yeah, synthesized under magnetic field. And study is a structure photocatalytic activity relationship. It is hypothesized that the well-aligned orientation will provide a good electron diffusion due to the molecular alignment of the titania and will act as a good photocatalyst. If we look at the literature, we found out that a very little research related to the effect of the magnetic field for synthesizing of well-aligned material. This is examples of the two papers, yeah, on the synthesis of materials carried out by the Japanese researchers. So this is the hypothesis. Yeah? Well-aligned titanium dioxide with a very high length to diameter ratio could be synthesized under magnetic field by sol gel method with liquid crystal as the structure aligning agent. Yeah, the approach is very simple. Yeah, by using liquid crystal 5CB, and the hydrolysis need to be controlled by adding water and alcohol in different ratio. So the combination of the liquid crystal 5CB and also the precursors, that is a tetrabutyl orthotitanate, is placed under strong magnetic field and leave in open air to remove the solvent by evaporation. It took more than 1 day to evaporate the solvent. This is the SEM image. We can see that with the magnetic field, we can see that the alignment of the materials. Yeah. This is the detailed step of the preparation of an aligned titania composite containing liquid crystal. It's very easy. Just mix of the precursor of the titania, water and alcohol, and also the liquid crystal placed under the homemade magnetic fields apparatus. And the most important factors that is hydrolysis. We need the slow hydrolysis. Why? Because we need to to align the titanium dioxide and the liquid crystal. So the alignment need more time. Yeah. So that we need slow hydrolysis. Yeah. It needs a slow hydrolysis. Yeah. And we characterize the electronic properties. This is the direct current electric. We can see that the well-aligned titanium dioxide containing 5CB have the more direct current electric compared to the non-aligned materials. And also this is a Hall effect. You can see that here that the Hall effect of the well-aligned is more compared to the non-aligned materials. Yeah, this is the same image, yeah, of the titanium dioxide sample synthesized under magnetic field and without magnetic field. We can see that with the magnetic field, we can produce a well-aligned. And these results of the photocatalytic conversion of the styrene demonstrates that the well-aligned titania 5CB composite gave a higher conversion compared than non-aligned materials. This is the fluorescence spectra of the titania 5CB synthesized under magnetic field and without magnetic field is also different. Yeah, it is related to the difference of the electronic properties and hence charge transfer during the photoirradiation. So we clarify the charge transfer mechanism using density functional theory. It is demonstrated that electron from the 5C liquid crystal jump to the titania, and the whole of the titania transfer to 5C liquid crystal. Okay, now we go to examples number 2. Yeah, examples number 2. That is the structure photocatalytic activity relationship over the carbon doped titanium dioxide analyzed by density functional theory and a fuzzy logic graph. Why? Because there is no comprehensive approach, yeah, to discuss currently the relationship between the physicochemical properties and the photocatalytic activity of the titanium dioxide. Yeah, whether is affected by the dominant factor is a crystal phase, whether the dominant factor is the surface area, doping, and electron hole recombination, and so on. Yeah. So in this approach, we use experimental works, yeah, and combined with the computational method, DFT calculation, by using DFT calculation, and mathematical approach by using fuzzy logic graph. So this is a fuzzy logic graph, yeah. For example, this fuzzy graph shows the relationship degree between variables nu1, nu2, nu3, and the nu4 to nu5. Yeah. From here, we can see that 0.5 is the largest membership value, which represent the dominant variables in this relationship. Therefore, a fuzzy graph can clarify the structure photocatalytic activity relationship of the titania photocatalyst. Why we choose a fuzzy logic graph? We choose a fuzzy logic graph approach due to the sum of the experimental data are imprecise, incomplete data, and usually we just have a small amount of experimental data. As the reason why we get only a small amount of experimental data and incomplete data is due to the higher cost of the sample characterization. Therefore, the fuzzy logic graph deal with the vague, indecisive ideas and subjective information depending on the degree of truth. Yeah, 0 to 1. Yeah, instead of the usual true or false. Yeah? 1 or 0. Yeah, so we can get the results from degree of the truth is the dominant factor of the physicochemical properties to the photocatalytic activity. So we choose carbon dope as a photocatalytic model because these samples we use since the carbon dope titania change the physicochemical properties, yeah, which enhance its photocatalytic activity, yeah. And number 2 is easy to synthesize and also easy to characterize. So in DFT calculation, we use supercomputer with a titanium structure, and we built the titanium structure from the experimental result of the literature, and all the molecular properties can be obtained by solving the Schrödinger equation. And we studied the effect of the carbon at different location, then amount of the carbon, yeah, effect of the oxygen vacancy, and effect of the structure distortion on the structure of the titanium. So we combine the fuzzy graph with the DFT, and in order to know the dominant properties, yeah, then we can use this as a future guidelines to synthesize the photocatalyst with the high photocatalytic activity. This table shows you the summary of the physicochemical properties from the characterization analysis and the percent of the styrene conversion from photocatalytic reaction of styrenes with the hydrogen peroxide. Yeah. And the FT calculation, we use a Gaussian software. Yeah. And we choose TI with the number of the Ti atom is 21 and oxygen is 30. Yeah, and we use in this method we use B2PLYP method. Yeah, in predicting the trend of the band gap energy. Why? Because this B2PLYP is have the better accuracy, yeah, in the predicting the band gap energy compared to the others method such as Hartree-Fock, yeah, and other modern hybrid functional methods. So we analyze the band gap energy of carbon doped titania using PDOS, yeah, and we can see that here the band gap energy is 0.03.06 electron volt. After the substitution of carbon at the titania lattice, the band gap energy was reduced, yeah, because of the formation of the sub-band energy. However, substitution carbon at the position, a different position, yeah, narrowed the band gap energy, yeah, and narrowed to produce 3.04 electron volt. But there is no creation of the sub-band energy. A similar result was observed for the carbon doped at interstitial position. Yeah. For carbon doped as interstitial position, carbon doped reduced the band gap energy by the creation of the sub-band gap energy between the valence band and conduction band. Yeah, at the interstitial or position. So therefore, the existence of the sub-band gap energy at the interstitial and the substitutional position, yeah, this is a substitute of the oxygen, increase the possibility of the carbon doped titania photocatalyst absorbed in the visible light irradiation. So this is the fuzzy graph, yeah, to study the structure photocatalytic activity relationship. We developed the CRISP graph from the physicochemical data and DFT result. Then we developed the fuzzy inference system model. After that, we calculate the membership value from the sensitivity analysis and fuzzy inference system model. The higher membership value represent the dominant properties that determine the photocatalytic activity of carbon doped titania under UV and visible light irradiation. Lastly, we developed the fuzzy graph from the membership value. This complicated graph is a CRISP graph that shows the structure photocatalytic activity relationship of the carbon doped titania. 13 variables have been identified. 12 is a physicochemical properties and 1 photocatalytic activity. The arrow represents the relationship between the variables. So the fuzzy graph shows that the surface area are the dominant properties compared to the other 3 variables on the photocatalytic activity, yeah, under irradiation by UV and visible light. Therefore, the surface area has show greater effect on the photocatalytic oxidation of the styrene, yeah, by carbon doped titanium photocatalysis. The amount of the electron hole recombined shows the lowest effects of the photocatalytic activity as compared to the other variables. Maybe the reason why the electron hole recombination only contributes around 9% is due to the photoluminescent analyzed relate to the electron hole recombination in the bulk of titania. Since the photocatalytic activity occurs on the surface, the electron hole recombination on the surface need to be taken into account in the photocatalysis. Unfortunately, the contribution of the surface electron hole recombination cannot be analyzed by photoluminescence since the contribution is very small relative to the bulk electron hole recombination. So lastly, we can conclude that the combination of the experimental work, computational method, yeah, DFT, and the mathematical approach by using fuzzy logic graph provide a better explanation on the structure photocatalytic activity relationship of the carbon doped titania. Lastly, I would like to thank my research group, my student, my postdoc, to to help this project done. Wassalamualaikum warahmatullahi wabarakatuh.